That simple act of taking a bite of food, it's not just the end of your hunger. It's the beginning of one of the most incredible automated journeys happening inside your body right now.
So, have you ever stopped to think about it? What really happens after you swallow? What looks so simple on the outside is, well, it's basically a high-tech, perfectly coordinated operation on the inside. So let's follow a meal from start to finish and see exactly how your body turns that food into fuel. Now, if you think digestion starts in the stomach, you're kind of jumping into the movie about 20 minutes late. The real journey, the transformation from plate to power, it kicks off the very second food passes your lips. That's right. Your mouth isn't just for chewing and tasting. It is a super sophisticated pre-processing plant. The moment you start chewing, you're initiating a critical chemical reaction that sets the stage for everything to come. And here's our first chemical superstar, ptyalin. It's a powerhouse enzyme hiding in your saliva. So let's say you're eating something starchy, like a piece of bread or some potatoes. Well, ptyalin immediately gets to work, breaking down those complex carbohydrates into simpler sugars before you've even finished chewing. The breakdown has already begun. And your saliva? Oh, it is so much more than just water. Your body produces an incredible 1.5 liters of it every single day. And it is packed with a security detail. You've got immunoglobulin fighting off germs and lysozymes that just straight up destroy bacteria. It is, quite literally, your body's first line of defense against invaders.
Okay, so once the food is chewed up and mixed with all that amazing saliva, it's ready for the next stage. This is where your body's incredible automation takes over, sending it down a one-way street with no turning back. Swallowing feels simple, but it's this perfectly choreographed sequence. Your tongue pushes the food back, your nasal passage seals up, a tiny flap covers your windpipe so you don't choke, and then these powerful wave-like muscle contractions just take over. You don't even have to think about it. Your body just knows exactly what to do. And this little fact just shows you how powerful that process really is. Those muscle contractions in your esophagus are so strong, they completely defy gravity. I mean, you could literally be hanging upside down, take a bite of a banana, and their body would still deliver it right to your stomach. It's just an unbelievable feat of biological engineering. And it is lightning fast. That whole journey down the esophagus takes just 6 to 10 seconds. And just like that bite of food has arrived at the main event, the stomach. Welcome to the core of the operation. We are now entering a powerful chemical factory where your meal is about to get seriously deconstructed. Think of your stomach as this muscular, J-shaped cement mixer. It churns and squeezes and mixes your food with incredibly powerful acids and enzymes, turning everything into this thick, soupy paste called chyme. Once it's the right consistency, it's sent on to the next phase of processing. Okay, so whoever named it the small intestine clearly had a sense of humor. The name is completely deceiving. If you were to lay it all out, it's an enormous workshop. As you can see, you've got these 3 sections, and together they stretch out to create this massive surface area for absorbing all the good stuff from your food. Right, so this is where the real heavy-duty absorption happens. As that chyme enters the first part of the small intestine, it gets hit with reinforcements, like bile. Bile is produced by your liver, and it basically acts like detergent for fats. It takes these big, greasy globs and emulsifies them, breaks them down into tiny, tiny droplets. This gives your enzymes a much bigger surface to attack, making the whole process way more efficient. Now, none of this just happens by accident. The whole process is tightly regulated by this brilliant communication network. So let's take a look at the messengers and the managers that keep this whole factory running in perfect sync. First up, let's talk about the command center, the liver. It weighs in at about 1.4 kilograms, that's just over 3 pounds, making it the largest gland in your entire body. And believe me, it is an absolute powerhouse. Calling the liver a master laboratory is no joke. I mean, look at this job description. Every nutrient absorbed from your small intestine goes here first for processing. It's also your body's main detox facility. It creates the proteins that help your blood clot. And of course, it produces that crucial bile we just talked about. The liver is involved in literally hundreds of vital functions. It's the unsung hero of the body. So how does the liver, the stomach, and the whole system know what to do and when to do it? The answer is hormones.
You can think of them like tiny little text messages. They're chemical messengers that travel through your bloodstream, carrying very specific instructions to target cells all over your body. And getting that messaging just right is absolutely critical. Just take a look at the thyroid gland, for example. If it sends out too many hormonal messages, that's hyperthyroidism. Your whole system goes into overdrive. But if it sends out too few messages, hypothyroidism, everything slows right down. It is such a delicate and important balancing act. So as we zoom out from all these individual parts, what we start to see is not just a series of organs, but this incredibly complex, interconnected, and intelligent machine, all working together in perfect harmony.
The elegance of it all is just stunning, isn't it? That one simple bite of food gets transformed through a perfect symphony of mechanical force and chemical precision, and it's all for one reason, to power the trillions of cells that make you, well, you.
And this intricate factory, it works tirelessly, 24/7, without you ever having to think about it. But the whole system is so interconnected, it's like a perfect chain of dominoes, which leads to a pretty important question. What happens to the entire assembly line when just one of those dominoes falls?